There we go.
Alright, Nathan says action. So good morning, boys and girls. Today in 8th grade math, we're working on finding the lines of best fit. This involves...
And if you want, you can like or subscribe.
Once again, you don't have to, but he insists on that, saying that in multiple videos now. Alright, so...
But you can if you want.
Okay, so given a scatter plot, for a line of best fit, we're going to try to approximate what line works best. I warn you, he's becoming more and more hyperactive. I don't think social distancing is good for 6-year-olds. Now, how this works is we're going to approximate this with the line we draw in. So, we're trying to find what works about the best. So I think a line like that is about as good as we're going to get. Now, when you're in 10th grade, you're actually going to use graphing software programs in order to actually find the exact equation. In 8th grade, you just have to be able to do it visually. So remember, an equation is y equals mx plus b. B is the y-intercept. This graph seems to cross, the line it crosses approximately at 2. The slope, how much it goes up, how much it goes over, it's about 1. So 1x plus 2. So for our data, our best approximation for a line to make it work is 1x plus 2. Sorry, what?
If you saw the inner videos.
They have been watching the videos. So that is one way you're going to have to do this write these equations is from a graph. Basically, you go off of about where it starts, the line, and you try to approximate the slope. The slope won't be perfect, but you're going to use an approximation. The assignment's also going to have you use tables, so if my hyperactive co-host will want to erase the board for me. Nathan, can you erase it, please?
Oh! You're done with this?
Yep.
Oh boy. This is too high.
I'll erase if it's too high. That's good. Now guys, get rid of this stuff too.
I have to keep the off there, right?
Yeah, keep the words up there. Alright, now we're going to create a table and use it to help us predict the future as well. This is what we do. Not sure why he's pushing me out of the way, but you know, whatever. Okay, so if you're going up by the x values, in order to find the slope, we have to see how much you increase each time. 10 to 12 is an adding of 2. 12 to 15 is an adding of 3. 15 to 16.5 is adding about 1.5. So we take the approximate average to find the slope. In this case, it seems to be about 2. So we're going to write y equals 2x. To find the intercept, the y-intercept, the b value in y equals mx plus b, we want to go back. So if we're adding about 2 each time, 2 before 10 is... You know, Nathan? What is 10 minus 2?
10 minus 2?
Yeah. You have 10 fingers and you take away 2. How many is left?
1, 2, 3, 4, 5, 6, 7, 8.
8. Alright. Now, we're going to find the fifth when x equals 5. 2 different methods here. Now, we're approximating for the future here, and this is going to tie into what we're doing the next day as well, is we can use the equation, or we can just go off the trend here. 16.5 plus the 2 we're seeing is about 18.5 approximately. Or we could plug x equals 5 into the equation. 2 times 5 plus 8 equals 18. 2 times 5 is 10, plus 8 is 18. Either way works. And then you say, Mr. Davis, these are different answers. We're just approximating. We're not going to be exact. Also, there's no guarantee it's not actually 12 or something here either, because when you start trying to predict the future, it's no guarantee. But this is a better estimate than anything we can come up with on our own. Now, in today's multiple choice assignment, if they said 18 or 17 or 19, I'd consider those reasonable approximations. Okay. Now that Nathan's making more facial reactions, do you want to say goodbye? Because we're done talking.
Bye bye.
Thank you once again. See you next time. Do you stop it? Nope.